Hi, in this video, we're going to look at simple inequalities. Now, in previous sections, we have looked at equations where x was equal to a specific value, such as x equals 3. In inequalities, we are going to look at examples where the variable takes on more than one value. An inequality tells us about the relative size between values, and a value is bigger or smaller than another. Let's start with greater than. This sign looks like an arrow pointing to the right. The bigger value goes on the bigger side, and the smaller value goes on the small, pointy side. Let's say that Brittany and Kim run a race. Brittany wins. Who is faster? If Brittany wins, then she is faster than Kim. We may not know their actual speeds, but we know that Brittany's speed has a bigger value than Kim's. So we can say B is greater than K. Now let's look at smaller than. The sign for smaller than looks similar to the sign for greater than, except the arrow points in the opposite direction. Here, we still put the smaller value on the smaller pointy side and the bigger value on the bigger side. Let's say that Andrew and Thomas are brothers. Andrew is 12 years old and Thomas is 15 years old. Let's compare their ages. Andrew is younger than Thomas, so the value of his age is smaller. So we can say A is smaller than T. Now let's look at greater than or equal to. This sign points in the same direction as the greater than sign, except now it has an additional line. The line looks like the bottom half of an equal sign, and this is how we determine the difference between greater than and greater than or equal to. On Friday night, John and his friends go to a movie. You must be at least 13 years old to watch the movie. How old are the people in the cinema? We don't know anything about the specific ages of the people in the cinema, but we do know that everyone is 13 years of age or older. So we can say the people's ages are greater than or equal to 13. Finally, let's look at smaller than or equal to. This sign is similar to the sign for greater than or equal to, except once again, it is pointing in the opposite direction. Let's say that a local radio station offers a competition to students up to the age of 21 years old. How old are the students in the competition? Again, we don't know the actual ages, but we know that everyone is 21 or younger. So we can say the students' ages are smaller than or equal to 21. In this course, you will need to show inequalities on a number line. Using a number line helps us to see which numbers are bigger and which are smaller. The number on the right is always bigger than the number on the left. Here, the blue numbers to the right of 0 are positive, and the red numbers to the left of 0 are negative. It is impossible to write down a completed number line because numbers go from negative infinity to positive infinity. The number lines that we draw are just small snippets of a larger line. The arrows on the left and the right show the number line goes on forever. When working with number lines, we need to draw a dot above the given value. If we are working with greater than or smaller than, then our dot will be hollow. If we are working with greater than or equal to, or smaller than or equal to, then our dot will be a solid. A hollow dot is simply a circle that is not colored in. A solid dot is colored in. Let's look at an example. X is smaller than 2. Let's start by drawing our number line. Here we have x is smaller than 2. 2 is our given value, so we need to put a dot above 2 on our number line. We can see that x is smaller than 2, so we use a hollow dot. This inequality tells us that x is smaller than 2. That means that x can take on any value that is smaller than 2. Every value between 2 and negative infinity. Now, there are a lot of values, so we can't draw dots on the number line for every possible value of x. Remember that everything to the left on a number line is smaller than everything to the right. So, to show that x is smaller than 2, we draw a horizontal line from 2 to the left of the number line, like this. Just like the arrows on our number line, the arrows in our blue line show that the values of x go on to negative infinity. Now we have x is greater than negative 3. Let's put on our number line. You can make your number line as big or as small as you want to, but my basic suggestion is to include about 7 values, as this will give your teacher and your examination marker a good idea of what you're trying to show. In this case, x is greater than negative 3. Negative 3 is our given value. X is greater than negative 3, so we put a hollow dot above negative 3. Remember that values to the right are greater than values to the left. X is greater than 3, so we draw a line to the right of negative 3. Let's do another one. In this case, x is smaller than or equal to 4. It is smaller than or equal to 4. So we need to put a solid dot above the 4. We are looking at smaller values, so we draw our line to the left of 4. Let's do one more. X is greater than or equal to negative 1. It is greater than or equal to negative 1. So we put a solid dot above negative 1. We are looking at values that are greater, so we draw a line to the right. In this course, you'll be asked to use interval notation. It is not always easy to write down all the possible values of a given variable. So we use interval notation to show the lowest and highest possible values that makes an inequality true. The lowest value goes on the left and the highest value on the right, and the values are separated by a semicolon. Once again, let's look at x is smaller than 2. X can take on any value smaller than 2. So 2 is our highest possible value. So you can write 2 over here. We have no lower bound. So the possible value of x goes on to negative infinity. In interval notation, we can then write negative infinity as our lower bound. So we can put that in over here, and we separate with a semicolon. Now we need to look at our brackets. X is smaller than 2, but this does not necessarily mean that the highest value of x is 1. X could be 1,9999999 forever. It just can't be 2. So when working with interval notation, we use a round bracket if we're working with greater than or less than. This tells us that x can be any possible value smaller than 2, but it does not include 2 itself. Negative and positive infinity do not have actual values because positive and negative numbers go on forever. So we always put round brackets around negative and positive infinity. Now we can put a round bracket around negative infinity and a round bracket around 2. Let's look at x is greater than negative 3. Here, x can take on any value that is greater than negative 3. So negative 3 is our lowest possible value. So we can write negative 3 over here. X takes on values greater than negative 3, but we do not have a higher bound. This means that the value of x can go on to positive infinity. So we can write positive infinity as our higher bound. Please remember that when using interval notation, the smaller value is always on the left and the bigger one on the right. Now let's fill in our brackets. We have just said we use round brackets when working with negative or positive infinity. So we can put a round bracket over here. Our inequality includes a greater than sign. So x can be anything greater than negative 3. This means it can be negative 2,99999 and so on, just not 3. So just like our previous example, we can put a round bracket around negative 3. And this shows us that our value of x can be anything down to negative 3, just not including negative 3 itself. Here we have x is smaller than or equal to 4. We are looking at all values smaller than 4, but we are also looking at 4 itself. In this case, 4 is our upper bound. So I can put 4 over here. Once again, we don't have a lower bound. So x can take on the value of 4 or any possible value smaller than 4. And it can go on until negative infinity. We know that we use a round bracket when working with infinity. So we can put this in now. When working with an inequality that is greater than or equal to, or smaller than or equal to, we use square brackets. So in this case, we can put a square bracket around our 4. This tells us that x can be any value smaller than 4, but includes 4 itself as well. Let's do one more. X is greater than or equal to negative 1. Negative 1 is our smallest possible value, and the values of x can go on forever. So infinity is our upper bound. So we can say negative 1 is our smaller value, and infinity as our greater value. We always put a round bracket around infinity. X is greater than or equal to negative 1. So we need to put a square bracket around our negative 1. This shows us that x can take on any value greater than negative 1, but also includes negative 1 as well. Please work through some questions in this section before you move on to our next video.